This is the first part of the second lecture from Module 8 of the Apologia General Science book. This lecture is on uniformitarianism and catastrophism. Last time, we talked about the fact that this module is summarizing Module 6, which was about the geological record, and combining that with Module 7, which was about the fossil record. We're going to take a look at both of these today and see how the geological record and the fossil record give us the data to try and determine whether uniformitarianism or catastrophism fits that data better. Last week we looked at how the uniformitarianist looks at the geological record and the fossil record, and then we also looked at how the catastrophist looks at the geological record and the fossil record. We talked about how the uniformitarianist takes portions of from different regions around the world, different layers of rock that have been dated by these index fossils. And then the uniformitarianist takes these different regions, meshes them or puts them all together to form the geological column. Recall that this column is a theoretical picture in which layers of rock from around the world are meshed together into a single unbroken record of the Earth's past. It's very important that you remember that you cannot go anywhere in the world and find all of these layers in one place. This column was put together by meshing or combining layers from around the world based on those index fossils. Continuing our review, remember last time we talked about the first assumption that's made when making this geological column. And that assumption was that each layer of rock represents a period in the Earth's past. Now we talked about how this assumption comes into question when we look at local catastrophes like Mount St. Helens, for example, where layer upon layer upon layer of stratified rock was laid down in less than a day. Therefore, this assumption does cause us some questions, because we need to remember that each layer of rock does not necessarily represent millions of years in Earth's past. The second assumption that we talked about last week was that index fossils are accurate indicators of which time period the rock or layer of rock was formed. We spent a lot of time talking about this and how there's a couple reasons that that we would question this assumption. First of all, these index fossils, in order for them to be accurate, have to be extinct. And we noted a couple examples of index fossils that were thought to be extinct, but then later they found living examples. And therefore using those as index fossils was incorrect and would give wrong results. Another reason that these index fossils are probably inaccurate is the method that's used to date them, either carbon dating or radiometric dating, which is just not reliable for things beyond a few thousand years old. Certainly not things that are thought to be 200 million years old. Well, let's say, for example, that we're going to assume for a moment that these assumptions are correct. And if these assumptions are correct, then it is very, very logical and reasonable to draw this first conclusion, that you can construct a theoretical geological column which shows life forms gradually getting more and more complex. If assumption 1 and 2 are correct, it makes a lot of sense to construct that geological column. And if that geological column is constructed, then it's very logical to draw this second conclusion, that all life on this earth has one or a few common ancestors that existed a long time ago. and that is the theory of evolution. So as I mentioned last time, if you're talking with someone who believes in evolution, you really aren't going to get very far in convincing them that that theory is inaccurate just by arguing conclusion 1 and 2, because those make a lot of sense and are very logical. Really, what you need to talk about are these assumptions. Because if assumption 1 is shown that it's not necessarily true, that these layers of rock don't necessarily represent millions of years, and if you can show that that assumption isn't necessarily right, then those conclusions basically come tumbling down. In the same way, if you can talk about the fact that these index fossils are not accurate indicators of the time period the rock was formed, and if that assumption goes away, again, these two conclusions just cannot stand. That's the end of part 1 of this lecture.